Okay, in this system we have to find out the overall gain of this system. The overall gain will be y divided by x g. So first, this is a closed loop system with feedback minus h1. So corresponding to this block we will have g1 divided by 1 plus g1 h1. To this block g2 is connected in series, so overall will be g1 g2 divided by 1 plus g1 h1. For this block we have, for this system we have g1 g2 divided by 1 plus g1 h1, and to this system we have a unity feedback. For unity feedback the closed loop system will be g1 g2 divided by 1 plus g1 h1 divided by 1 plus g1 g2 divided by 1 plus g1 h1. This will give you g1 g2 divided by 1 plus g1 h1 plus g1 g2. Here we have to find out the steady state value of the steady state error ESS. Okay, GS is given, the open loop transfer function. So the steady state error or the Laplace of a steady state error ES will be Laplace of input minus Laplace of output, XS minus YS, and YS will be XS into the input into the system transfer function, the closed loop transfer function, YS will be input into closed loop transfer function. XS is 1 by S minus 1 by S, and the closed loop transfer function will be GS divided by 1 plus GS. So ES is 1 upon S into 1 minus GS divided by 1 plus GS. This will be 1 upon S into 1 divided by 1 plus GS. And to find out the steady state error, the value of ET, the steady state means t tends to infinity. This will be SES, applying final value theorem, limit S tends to 0. So S into ES is this, 1 upon 1 plus GS. So S will be cancelled. So basically we have to find out 1 divided by 1 plus GS when S tends to 0. 1 divided by 1 plus GS, and in GS we need to put S tends to 0. So this quantity is also called as, this is Kp. This is error constant for unit step. This is error constant for step input, or this is also called the phase error constant. So for unit step the error is 1 upon 1 plus Kp. Similarly for ramp input, this will be 1 divided by Kv, and Kv is limit S tends to 0 SGSHS, and Kv is called velocity error constant. Okay, so we have to find out value of GS when S tends to 0. So if S tends to 0 in this equation, this will make the denominator 0 and this will give you infinity. So here we will have 1 upon 1 plus infinity, and this will tend to 0. So the steady state error will be 0. In this question the open loop transfer function is given and the feedback is 1, means it is a unity feedback system. This is a negative feedback, so there is negative unity feedback, and we have to find out the location of breakaway point on the root locus diagram of the system. So to find out the breakaway point, we will have 1 plus kgshs equal to 0. Okay, if a point is on root locus, 1 plus kgshs will be 0. This equation will be satisfied, and we will find k equal to -1 divided by gshs. So k will be -1, and gshs is this is kgshs is given as, this is kgshs. So k will be -1 divided by, this will be gs, s plus 2 divided by s square plus 2s plus 2, and hs equal to 1. So k will be minus of s square plus 2s plus 2 divided by s plus 2. So dk by ds, we will first equate dk by ds to 0. It means s plus 2 into differentiation of this, taking minus out, 2s plus 2 minus s square plus 2s plus 2 into differentiation of denominator 1, and whatever denominator is, denominator square will be 0. So this will go to 0, minus will go to 0. So here we have 2s square plus 2s 4s 6s plus 4 minus s square minus 2s minus 2 equal to 0. S square 4s plus 2 equal to 0. So we will get two values of s equal to -4 plus minus b square minus 4ac divided by 2. We will get -2 plus minus root 2. S1 is -2 plus root 2, and S2 is -2 minus root 2. And in the theory of root locus, we have studied that whatever values of s, that is s1 and s2, we are getting by equating dk by ds to 0. This is not necessary that both will be the breakaway point. So to check which point is the real breakaway point, real means which is the actually breakaway point, we will check whether out of these 2 points which is lying on the root locus and which is not lying on root locus. So to check whether it is lying on root locus or not, if a point S1 is lying on root locus, then the angle of GSHS at that point S will be equal to 180 degree. This is one method. So we have value of GSHS, put these two values of S, and if that quantity is real negative, the angle will be 180 degree. If that quantity is other than anything real negative, anything but not real negative, that means if by putting S1 or S2 the value of GSHS is positive or complex, the angle will not be 180 degree and that point will not be on root locus. So this is one method. The another method is, if you have practice of root locus, we will quickly see the nature of root locus, and by observing the nature of root locus also we can observe very easily whether out of these 2 points which is lying and which is not lying. In the root locus, GSHS is equal to s plus 2 divided by s square plus 2s plus 2. The location of 0 is at -2. This is -2, and the poles will be, if you will equate to 0, you will get S equal to -1 plus minus j. This is -1, so this is -1 plus minus j, and this will be -1. This is -1 plus j, this is -1 minus j. Now if we talk about this part of real axis, there is no poles or 0 to write off this real axis, so this part will not be on root locus. If you talk about this part of real axis, there is 1 0 which is odd, so we have odd number of poles and 0 to the right of this section of real axis, so we will say this axis will be on root locus and this axis will not be on root locus. Now we have two options, -2 plus √2. So this point -2 plus √2 will certainly be right to the point -2. This will lie somewhere here, and this is not on root locus. So this point is not on root locus. If we talk about this point, so this point will certainly lie left to the point s equal to -2, and all the points which is left to -2 are on root locus. So this is actually on root locus. So somewhere here we will have a breakaway point. So the root locus will be like, okay, then it will have breakaway. One root will terminate to 0 and other will terminate to infinity.